Okay, plan for this recording is to talk through ellipses, how to graph them, how to find equations, etc. So, on the screen there is a generic form of an ellipse. H and K, just like the circle, is my center of the ellipse. The A value in this particular way it's written is how far it goes in the x direction, and the B is how far it goes in the y direction. Nothing special about the A and the B. They could be flip-flopped. Some texts say no, they have to be rigid in certain spots, but it really doesn't matter. It does when you come to finding the foci, but we'll talk about that down the road when we get there. Okay, so the way this is written, with a centered H and K, A is how far I go in the x direction, B is how far I go in the y direction. How do I know that? Because they're underneath the x's and they're underneath the y's. Whatever is underneath the x, that's how far it goes in the x direction. Whatever's underneath the y, that's how far we go in the y direction. All right, so I talked about all this stuff, but what is an ellipse? Not a circle, but it's something like a circle. A circle goes the exact same distance in the x and the y direction and makes a circle. So an ellipse is an elongated circle, like an oval. Okay? So an ellipse goes a different amount in the x compared to the y. All right? So let's graph one. So what if I had, let's do an easy one, x squared over 16 plus y squared over 25 equals 1. So the center, H and K, there's nothing there, so my center is at 0, 0. So on my graph, my center is at 0, 0. In the x direction, I go 4 units. In the y direction, I go 5 units. And I sketch my ellipse. When you're drawing these, the tendency is to curve towards your, it's a vertex, we don't know that yet, towards your vertices too fast. Try to stay flat for a while, make it look like a track, like a running track. Okay, it stays flat, stays straight for a while, then it curves. It doesn't go like this. That's not an ellipse. Okay, keep it flat for a while. All right, so there's my ellipse. We have some key things. We have what's called vertices. These points here are my vertices. The 4 points we plotted, those are my vertices. So in this case, my vertices are at 4, 0, negative 4, 0, 0, 5, and 0, negative 5. Okay? My focal point. Your ellipse will always wrap around your focal points. Next video. Your hyperbolas will also always wrap around the focal points. Okay? So, where are my focal points? Your focal points are always on the major axis. What is my major axis? The axis that is longer. It is going, we go further in the y direction than we go in the x direction. So my focal points are always on that major axis. Okay? Now, in general, the definition of an ellipse tells me that I have focal points sitting out here somewhere. I don't know where they're at right now, but I will put them there in a second. So I have some focal points just sitting out here somewhere. And the distance between that focal point, or each focal point, and let's say this point on my graph right there. If I add these two distances together, the distance from that point on my graph to both focal points, if I add that distance together, it will always be 2a. That's the definition of an ellipse. It'll always be the same distance away. This distance plus this distance plus this distance. They're all the same. And that length happens to be 2a. What is A? A is the distance from my vertice on the major axis to my center. That's A. Remember what I said, it's not, we don't have to be picky about which one is A. This could be A or this could be A. Well, now we kind of have to be. That's my A value. The length on the major axis, which one's bigger? Okay, so I'm going to pick a point, a special point, that one right there. So what we just said was this distance plus this distance is 2A. Well, don't you agree that by symmetry, these two lengths are the same? So that length is A and that length is A. Get rid of something here. So if that's A, by definition, this was B. So let me make this a little easier. Let me swap these two things here, because it doesn't really matter, but the longer one is always going to be A. So in our particular case, the A is longer, so that's my A. So then this distance here is B, and the definition of C is the distance from the center to the focal point. So that's C. Give me a second to copy that down. So what do we have? Like we talked about in circles, we have Pythagorean theorem. We know Pythagorean theorem. So in this case, B squared plus C squared equals A squared. Now I know most of you are saying, well, wait a minute, I thought A squared plus B squared equals C squared. Well, it does, but our letters just don't work out that way. It is the length of the sides squared equals a hypotenuse squared, right? That's the Pythagorean theorem. And my lengths of my sides happen to be labeled B and C. And the hypotenuse happens to be A. So for the ellipse, it's B squared plus C squared equals A squared. For the ellipse and the Pythagorean theorem, your A is always the longest side. So when I look at my ellipse, these two things are interchangeable depending upon which one's bigger. A always corresponds to the bigger length. Longer length. Lengths aren't big. Sorry. Get my terminology correct. All right, so let's find our foci. These are called focal points, or plural foci. There's a point there, and there's a point down there. There are two focal points for every ellipse. Okay, so let's find them. I know that B was 16. B squared, sorry, is 16. And I know that my A squared was 25. How do I know that? A squared, B squared. It tells me what B squared and A squared are. Doing some little solving, I get subtract, and C squared equals 9, and so C equals 3. The length of my focal point, or the distance between my center and my focal point, is 3. Well, it's close. I was at 4. So it's going to be 3, 0, 3, and 0, negative 3. Those are my foci. There are not 4 foci like there are vertices. They are only on the major axis. Your foci are only on the major axis. A lot of times, those foci are not nice, neat points like they are here. Okay, we need another. Let's try. I don't want to go that hard yet. Let's go here. X minus 2 squared over 16 plus y minus plus 1 squared over 4 equals 1. Notice this is always a plus, this is always a 1. Otherwise, your patterns don't work. Okay, take a second, sketch a graph, Find the vertices, find the focal points, and come back when you've got it. Okay. Center is at 2, -1. My distance in the x direction is 4. 1, 2, 3, 4 in both directions. Sorry, I shouldn't have used 1. That put it right on the numbers. And -1 is my y, going 2 in each direction, that way and that way. So my ellipse looks even more like a track because the x and y distances are even further off. Okay, so there's my ellipse. Vertices are at 6, -1. They are at -2, -1. They are at 2, 1, and 2, -3. Okay, they are right here in green, right there, right there, right there, and right there. The 4 points you plot coming off of the center. Those are my vertices. Okay, foci. A squared equals b squared plus c squared. Which one's a squared? The 16 or the 4? Well, the larger one. So 16 equals c squared plus 4. So c squared equals 12. And so c equals plus and minus the square root of 12. Let's write that in simplified radical form. What perfect square goes into 12? 4, right? So I can break 12 into 4 and 3, and the square root of 4 is 2. So that becomes plus or minus 2 square roots of 3. That is the length from the center to C. Which way? Horizontally or vertically? I start at the point 2, -1. Do I count in the x direction or in the y direction? Major axis, the longer one. I count in the x direction. So I started at 2, and I'm going to add, and I'm going to subtract 2 square roots of 3 to that number. And the y-coordinate will not change. There's my foci. What is the square root of 12? Well, the square root of 9 is 3. The square root of 16 is 4. It's pretty close to the middle. It's somewhere around 3.5, 3.3, 3.4. So I go out 3 point something units in each direction. We're almost out to the vertices. One hint. The more elliptical, meaning the less circular it is, the closer your vertex or your focal points will be to your vertices. The more circular it is, the closer your focal points will be to the center. And if your focal points are at the center, it is a circle. You don't have focal points anymore. All right, that's something to help you when you're graphing them. All right, there you go. There's the ellipses. How to graph them, how to find the focal points, and the vertices. Let's do one more. And then I got one more hard one for you. Let's practice one more, though. All right, we have x plus 2 squared all right, give it a try. All right, my center is at -2, -3. We're sitting down here. We're going out 5 in the x direction. And we're going up 1 in the y direction. Now, I could have written it like that. I didn't need that 1 underneath there. Okay? All right. So my ellipse is very elliptical. I'm going to expect my vertex or my focal points to be right out at the vertices, almost touching them. Okay, so there's my ellipse. I know my center. So if it asked, my center is at a -2, -3. My vertices are at 3, -3, and at -7, -3. Going out 5 in each direction from -2. And my vertices are at -2, -2, and at -2, -4. Going down 1 in each direction from my y-coordinate of my vertice. All right, focal point. 25 equals c squared plus 1. 24 equals c squared. C equals plus or minus. 24 can be broken down into 4 and 6. So 2 square roots of 6. Correct? 24, the square root of 24 is very, very close to the square root of 25, right? So my focal points are very close to my vertices. I add them to the x-coordinate again because I'm going in the horizontal direction. So -2 plus and minus 2 square roots of 6, and the y-coordinate is a -3. And there's my foci. Okay, harder one. Write the equation for the ellipse, or it could say sketch a graph of that ellipse, find the foci, all those different things. But let's put that in standard form. Then you can answer all those other questions, or any other question you want to answer. Put that thing in standard form. Remember, from a circle, we have to complete the square. This one's a little harder. If you think you've got it, hit pause and give it a try. If not, here we go. First step, group my x's and my y's together. So 9x squared minus 18x, leave myself a space, plus 4y squared plus 16y, get rid of the constant. Step 2, this was not on the recording about circles, but it was on the recording about completing the square. First step, coefficient of the squared term must be 1. The coefficient of my squared term must be 1. I'm going to factor out whatever is in front of the x squared. And when I say factor it out, I mean divide it out of just those terms. So just out of the x terms or just out of the y terms. Dividing 18 by 9 gives me 2. Leave myself a space. Divide out or factor out the 4. Leave myself a space. Now, figure out what you have to add to complete the square. Divide the coefficient of x by 2 and square it. Divide the coefficient of y by 2 and square it. Now, here's the hard part. Not hard, just you got to remember to do this. When I factor, rephrase that. If I were to multiply this out and go back up to here, I should get the exact same equation as I have above. Well, if I distribute this 9 to these 3 terms, what will I put right here? Plus 9, right? So what I really just added to the left-hand side of this equation, when I put a 1 right there, what I really added was 9. So what do I have to add on the right-hand side to balance the equation? 9. And if I were to distribute this 4 out, what would I really add right here? 16. So what do I have to add right here? 16. Don't forget to do that. The number out in front that you factored out must be multiplied by whatever you add, and that is what you have to add to the other side to balance the equation. All right, let's factor. This factors into x minus 1 times x minus 1, which is x minus 1 squared. This factors into y plus 2 times y plus 2, which is y plus 2 squared. And this gives me 36. Standard form for an ellipse has this 36 as a 1. How do I make a 36 a 1? I divide everything by 36. So the 9 goes into 36 once and 4 times. So I end up with x minus 1 squared over 4. And I get y plus 2 squared over 9 equals 1. Now, most of the time, those will come out to be nice, neat numbers where they are all factors and so on, but they don't have to. Okay? Now, I assume you can do the rest of that because we just did 4 problems like that. So if you wanted to find the equation of the, not the equation, if you wanted to graph that, find the focal points and all that, you can. Give it a try if you want another one. If you don't, nice job. Okay, let's try this thing. First step, let's group the x's and the y's together on the same side of the equation, and let's leave the term that doesn't have anything in it, like the constant, alone. So I'm going to move that 9x squared over here and make it a positive 9x squared. And then I have my 54x. Then I have my y squared. And I have my 2y. And it equals 46 negative. All right, that's an x. Can't read my own writing. Factor out of 9. I get x squared minus 6x, right? Plus nothing has to come out of the y. Divide the 6 by 2 and get 3. Square it, and I get 9. So what I really just added was 81. Right? 9 times 9. I'm going to divide 2 by 2 and get 1. Square it, I get 1. So I add 1. 82 plus 46, or minus 46, is 36. Left-hand side, 9x minus 3 squared plus y plus 1 squared. Divide by 36, I get x minus 3 squared over 4 plus y plus 1 squared over 36 equals 1. Looked bad. Came out all right. All right, that is ellipses.